Bluetooth device is ready to pair.
Hello, mga palabra kumanta.
The Bluetooth device is connected successfully.
Hello. May buntag ka na akong tanan. I am very ready for my new vlog. My gosh. Welcome to my YT channel, Health, Safety, and Music. Okay, channel. Okay, and also science. Okay, so our topic for today is Citric Acid Cycle for human health. Okay, so let's start immediately. But before anything else, nagbukal-bukal ang akong tiyan. Oh. Wait for a while. Okay, at your service. Okay, again. So before anything else, I will draw a cell like this. Okay, cell. Okay, I will draw a very big cell. Okay, like that, and then there is a mitochondria here. Let's see here. Mitochondria also as well here, and we have also here DNA here, our DNA. That. Okay, our mitochondria here. Okay, here also. Okay, like that. Okay, this is our. This center will be the fluid. Okay, the jelly-like fluid, okay, in which glycolysis occurs. Okay, the cytoplasm. Okay, cytoplasm. Let's review a little bit of biology, right? Second year high school. Okay, cytoplasm, then mitochondria here. Okay, mitochondria. Okay, actually this is mitochondrion, but 1 plus 2 is mitochondria, plural. Okay, you get the point. Things like that, and we have here is the outer cristae. Wow, may ganon. Outer cristae. Talaga. And this is our inner cristae. Ganon. Inner cristae and outer cristae are parts of mitochondria. Okay? Like that. And we have here in the center, we have mitochondrial matrix. Okay? Mitochondrial matrix. Okay? Like that. So, I think, memorization also will help a lot for this. And sometimes you have to understand where it is located, things like that, what are the functions, so that you can easily, remember, right? And then here we have such like this. Okay, we have for example, this is a vital organ. Example only, So this is a membrane-bound organelle. Wow, and this is also membrane-bound organelle. Organelle. Membrane-bound. This is membrane. This one, membrane. Okay. Membrane. This one is cell membrane. Here. Cell membrane. And then this is organelle. Okay? Organelle bound membrane chart. Okay? Things like that. So why I introduce this? Because our glycolysis is very important here. Okay? Here in the mitochondrial matrix also our citric acid cycle will exist here. Okay? Get the point. Okay, ganon. Okay. So, citric acid cycle. Okay. So, let's erase now. Just remember the few points. Mitochondria is the powerhouse of the cell, in which various substances are manufactured and processed within the cell. Okay. Cytoplasm is a jelly-like fluid in which glycolysis occurs. Things like that. Okay? You get the point. So, very basic, right? Okay, let's erase already. Capture, copy. Okay. Oh, klaro, di ba? Okay, I'll change this one. Okay, I'll change with black. Guys, ang hirap kumita ng pera, kailangan madami talaga yung videos. Okay? Oh my gosh. Okay, so since I have, full-time work, I cannot manage to perform a lot of videos. Okay? This is only part-time job. Part-time job and sideline job. Okay? You get the point. So, mga palangga, mga friends, please stay tuned for this very important citric cycle. Citric acid cycle. Okay? Citric acid cycle. Before going further, let's try to have the formula first so that we can understand. Citric acid cycle. Okay? Like that. Cycle meaning just like a circle, starting point, and then the last point will meet the starting point. So it will be round, things like that. Okay? That's cycle. So it goes back and forth, like that, and it will stop at the same initial point. Okay? That's cycle. Okay, citric acid, how can we determine this? Oh my gosh. We need to know Arrhenius theory. Arrhenius theory of acidity and basicity in organic chemistry. That's why inorganic chemistry is prerequisite of organic chemistry. Okay, get the point, because there are things that you should remember and you can apply that in organic chemistry also, as well as in biochemistry. Okay, get the point. So citric acid comes from citrate. Okay, citrate. Citrate is gonna be polyatomic anion. Okay? Polyatomic anion. Okay. Polyatomic because it contains a lot of carbon atoms, hydrogen atoms, like that. Okay? That's poly. Okay. Anion meaning negatively charged ions. Okay? Negatively charged. You will never say negative ions because it will never, if it is never charged, it is not called an anion. Again, this is not negative, okay, ion, because once it will become an ion, it will really charge. So the word charge is very important. Okay, so in chemistry grammar, if you will never put charge, you are wrong, because this is ionic compound. Okay, so the charges are very important. So it will become charged, and it will become an ion. Okay, so you will never say negative anion. You will say negatively charged anion or negative charged anion. Okay, so the word charge is very important. Do not delete the charge term when you speak during your discussion. Okay? Or you will say charge an ion or charge negative ion. Okay? As long as you will not remove the word charge. Okay? Things like that. Because it will never become an ion if it is never charged. Okay? Things like that. Okay, so that is polyatomic anion. That is citrate, but in terms of organic compound, right? So citrate. Citrate is a component most of the times for multivitamins and vitamins or supplements. It will be linked usually with ascorbic acid. It could be sodium ascorbate, like that, things like that. Okay, if you found sodium ascorbate, or let us say calcium ascorbate, and then like that, so citrate also will be there. Okay, they are complementary with each other because citric acid comes from citrus fruits. That's why it's citric. Okay, when we say citrus fruits, there's also ascorbic acid automatically. Okay, so they are partners. You got the point? So citrate is C6H5O7 negative 3. Okay, then, so this is citrate. So plus H, Arrhenius theory, right? Okay, positive hydrogen, okay, ion. Okay, so it will become HC6H5O7. Okay, things like that. Okay, and you need three, okay, here, see, you need three times hydrogen will be existing just to neutralize the nitrate, that citrate. That's why you will say, for example, okay, C6H5O7, C6H5O7, C6H5O7 to compensate with the, okay, 3 with this. Okay, and H1. Okay, ganon. O, di ba mga palangga akong vital? Okay. So, meaning to say, there are three citrates, so you need to put 3 in hydrogen to neutralize the chemical reaction. Okay? So, put 3 here. Okay? And you're only needing 1 hydrogen to compensate the citrate. That's why you don't have the subscript here from C6H57. Okay, you get the point? So things like that. So our chemistry teacher before, they're just telling that you have to reverse the charge. That is wrong, actually. That is only mechanism. That is not concept. Mechanism meaning technique so that you can easily understand. Okay? But concept is you will do that because it is based on the theory, based on scientific evidence that it's gonna be like that. Okay? Just like balancing the chemical equation through trial and error method. That is only mechanism. But it doesn't follow the theory. Okay? So theory means algebraic equation way of balancing the chemical equation is not accurate one. The same also like this here. Okay? You get the point? So, para lang to siya madali, our teachers told that it will reverse the charge of citrate will be going here and the charge of hydrogen will be going there. But actually, it's not like that when you explain. Okay? You need 3, okay, citrate, okay, 3 times citrate to compensate the neutralization reaction to hydrogen. That's why C6H5O7, 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 1, 2, 3. And this is 3, you have to put 3 in the hydrogen because this is the one you neutralize. Okay? And then you only need 1. Okay? 1 hydrogen. So 1 hydrogen is here. So meaning, this subscript here is how many times you need that particular element or let's say, salt to compensate the neutralization reaction. It's not the charge that you will be able to reverse. That is only mechanism. Since most of the times, it will be correct also. That's why, muana lang atong teachers na ibaylora ang charge. But actually, that's wrong. Based on my research. Okay? Like that. You get the point? So, this is the concept and the mechanism is just okay para madali. Okay, but sa ibang good, kung di natutuduan sila sa klaro nga concept, then usbon bitaw, mayabong magod ang estudyante. You get the point? So that's why you need to discuss based on the concept and the principle, okay, how it is being abiding the rules, okay? Rather than mechanism only, the way how it is being sequenced, the way how it is being patterned. It's not like that all the time because it doesn't attach the concept. The point, okay. So, for example, math always like that, right? Sequencing, patterning, like that. You get the point. But if you apply that in a equation, you will simply blank raised to the power 3. Like that. X, example, x raised to the power 3. You will say x times x times x. Right? Then that is also x raised to the power 3. Oh. So that is the principle. But if you just say x times x times x times x, it looks like really pattern, right? Patterning and sequencing only. You got the point? But the formula is x raised to the power 3. That's why x times x times x. Like that, okay? So, Muna siyang cancel. Okay, muna ang citrate guys ha. So, if we have H3C6H5O7, then take a look with the common. So, hydrogen here also, it's become 8, right? So, it will become C6H8O7. So, this is the formula of citric acid. Okay? Get the point. 6 atoms of carbon, 8 atoms of hydrogen, and 7 atoms of oxygen. That is citric acid. I emphasize because this is citric acid cycle is our title, and this is one source of energy also for human being. It's like ATP. Okay. Ganon. Okay, well, erase now. Klaro ba siya mga palangga? Marigutom ko. Okay, get the point. Kisa yung kay kunikuan. Naningkamot. Charot! Okay. Like that. So in other books or in the website, if you try to Google, things like that, citric acid cycle is also known as a Tri-Catbocylic Acid Cycle, and sometimes also known as a Krebs Cycle. Okay? But there's a difference when you illustrate the structures and components one by one, but generally, it goes with the same concept. Be careful also in the question, because sometimes it needs to be specific, sometimes general, like that. Okay, the point. Okay. If the question will say, blank is another term of tricarboxylic acid. Tricarboxylic acid cycle. Since you have two, we have Krebs cycle and citric acid cycle. So impossible that it will become a question because the students will choose tricarboxylic acid, and Krebs cycle is also known as the answer will be Krebs cycle. Okay? To the point. Ganon. Or pwede sa answer mo ang duha, pero if awkward siya, it's very awkward to put in the question. Okay? You get the point. Ganon. Klaro ba mga palangga o ako magipapas? Okay. Ganon. So magsugod na po dali-ari mga palangga akong hita. Charot. Okay. So for example, I have here, glycolysis. Okay. Glycolysis, and ako i-emphasize. Then after the glycolysis, here is the pyruvate oxidation. Pyruvate oxidation. And here will be now, after that will be now the citric acid cycle. Okay, like that. So we are only up to citric acid cycle because our topic is citric acid cycle. But after that, there's also another cycle, blah blah blah, so on. So, okay, the last step, this is the electron transport chain. Okay, but we stop on the citric acid lang, ha? The topic is citric acid cycle. Okay, okay. So glycolysis occur in cytoplasm. Okay, like that. Because this is very, this is very, what do you call this one, catchy. If you try to be in the examination, blank is the region of a cell where glycolysis occurs. So, A, nucleus, like that, B, mitochondria, ganun kasi C, endoplasmic reticulum, like that, D, plasma membrane, E, cytoplasm. Yung answer will be cytoplasm, ha? Okay. Now, your pyruvate oxidation and citric acid cycle will occur in the mitochondria. Okay? Specifically mitochondrial matrix. Okay, itong center sa mitochondria. Okay. So for example, the question also will say, citric acid cycle and pyruvate oxidation will occur in what type of a cell? What parts of a cell? Okay, your answer also, mitochondria or mitochondrial matrix. If general, your answer will be mitochondria. If specific in the multiple choice, then mitochondrial matrix, your answer. Things like that. Get the point. Okay. So if there are also mitochondrial matrix and also mitochondria, then choose the two. So sometimes in the board examination, there are also A and B only, like that. A and C only. C, none of the above. D, all of the above. Okay, be careful also, ha? Okay, things like that. You get the point. Oh, ganon. Okay. It's gonna be like, pero, before ko mapadayon mga palangga, ano sa kong coffee, uy, charot. Pwede ko magduma ka. Char! Okay. Nakakalok ako. Oh my gosh. So, where's my, my heater? Char. Okay. I need stimulant to activate my neurons. Stimulant. What is my stimulant? So specifically caffeine. Caffeine is an ingredient of coffee, and this can stimulate and energize your neurons and your brain things like that. Okay? Caffeine. So, tulo atoms sa formula sa caffeine. 10 atoms of carbon, 8 atoms of hydrogen, okay, 4 atoms of oxygen, like that. Okay, and nitrogen 2 atoms. Okay, 10, 8, 4, 2. Just memorize it one. 10, 8, 4, 2, meaning 10 atoms of carbon, 8 atoms of hydrogen, 4 atoms of oxygen, and 2 atoms of nitrogen. Okay, this is the formula of caffeine. Okay? So if we intake the caffeine, then it can activate our brain cells. It sends message to the brain, and then it will elevate the blood pressure. The more our blood pressure will elevate, the more will be activated, the more we are energized. That's the point. Things like that. And the more we release the stress hormones. Okay, so we will be activated, energized, arousal meaning active because of the stress hormone neonephrine. Okay, specific hormone neonephrine. Okay, this is also stress hormone. Okay, so that to avoid sleepiness. Chart. Okay, so go back. Dagan po i-insert guys, no? Okay, para dagdag kaalaman, right? Dagdag kinaalaman. Okay. Okay. So ganon. So the first one is, let's say we start with glucose, because glycolysis, right? Glycolysis. Okay. So glycolysis is the breakdown of glucose in the cytoplasm. Okay? You got the point. Ganun siya. So we have glucose. C6H12O6. Okay? Since that is a breakdown, okay, we need to cut into half this glucose. We take the 3 carbons of carbon or glucose in the upstream, and then we take the 3 atoms of carbon and downstream. Okay, upstream, downstream. So there are processes. But we focus only in the downstream or upstream because we have the same steps. That's why our result will be only times 2, times 2, times 2, like that, because it's the same. The cycle in the upstream is just the same as the cycle in the downstream. Okay, so this is the glucose. Okay, glucose is familiar with blood sugar, right? So it's gonna be like that. Okay, so who will produce the glucose? We need to scrutinize really, because it is not a magic. Okay, when the glycolysis reaction or process will give glucose, there's responsible chemical messenger hormone to do that. So which hormone responsible to break this a lot of glucoses? Okay, actually this is coming from glycogen, okay, and then take glycogen group of glucoses and we take the glucose there, so it is being cracked like that, and then we take the glucose here. You get the point? And it's gonna be the glucagon hormone Okay, the glucagon hormone, which will be excreted in the pancreas, okay, just beneath the liver. I think so, right? It's gonna be like that. The glucagon hormone will give the glucose, okay, to act as a precursor to our citric acid cycle or raw material in our citric acid cycles and things like that. Okay, so we take now the 6 atoms of carbon. Okay, 1, 2, 3, 4, 5, 6. 6 atoms of carbon, then we break into 3, 3, right? So it's gonna be like here. Three also. 1 upstream, 2, 3 downstream. 1, 2, 3, like that. So when the carbon atoms will become 3, so it's no longer glucose. It's already pyruvate. Okay, pyruvate. So pyruvate, like that. So we'll produce the pyruvate. What enzyme again will produce the pyruvate? Because it is not magic also. Somebody will catalyze the chemical reaction every time. So it is the pyruvate dehydrogenase enzyme. Okay, pyruvate dehydrogenase enzyme. Okay? So timanan din niyo guys ha, usually dehydrogenase din siya. Things like that, just like the, the conversion of, stearic acid to oleic acid, delta 9, like that. So there will be a D, desaturase, dehydrogenation, or dehydrogenase. Removal of hydrogen. Okay, why removal of hydrogen? Because that's oxidation, rapid oxidation of pyruvate. In this region, this is pyruvate oxidation. So the more it is oxidized, the more it will remove the hydrogen. Okay? Like that. Mag-review na po ito sa reduction and oxidation. A little bit, okay? Sorry. So that we can understand. This is pyruvate oxidation, right? Okay, so low ox. Low ox means loss of electrons. So the element will oxidize. Okay, meaning to say there's an increase of oxidation number. Okay, now Riga, meaning there's a reduction, okay, or gain. No, sorry, gain of electrons, kaya loss na lang atong oxidation. Ano na siya? Imantiman ang masayop ka, tanawin din mo. Okay, gain of, para bupaspas atong brain cells, gain of electrons, and then this is being reduced. The element will be reduced, okay, and then this is gonna be decrease in oxidation number, okay, like that. The only what you could say catchy and confusing a little bit, the one that is being oxidized in oxidation is the reducing agent. Okay, so meaning to say the element that is oxidized, that is also reducing agent. Here, in your gain of electrons or reduction, the one that is being reduced is your oxidizing agent. Normally, students will be confused because if they say the word oxidize, they will say automatically oxidizing agent because there are commonality in the term. But no, it reverse, huh? Okay, the element is oxidized, that is functioning as a reducing agent. If the element or substance is being reduced, then that is oxidizing agent. Okay, reverse. Sometimes it will be asked, what is the oxidizing agent? Like that. What is the reducing agent? And then the question will give only the chemical reaction, and you have to identify which the oxidation, which being oxidized, which being reduced, which is reducing agent, which is oxidizing agent. And then if you don't have an idea, there's a little bit of confusion. Okay? Get the point. Ganon. Here, oxidation. Pyruvate oxidation. Meaning to say, loss of electrons. Right? You get the point. Loss of electrons. So, the more it loses the electrons, of course, the hydrogen will remove. Okay? You get the point. So that's why dehydrogenation is our enzyme. Okay? You get the point, mga talanga kung hitan. Okay, so I will introduce you the formula of pyruvate. It's gonna be 3 atoms, okay? 3 atoms of carbon, because carbon is 3, right? Atoms. 3 atoms of carbon, hydrogen 4 atoms, and oxygen is 3 atoms. So C3H43. Okay? Ganon. You get the point? Ganon. Then if you try to focus also the entire perspective, you don't have to stop here. Huh? There's also on the another side after here. This glucose, right? Okay, like that. And then here in the pyruvate oxidation, it will produce also another, product on the other side. You get the point? So things like that. So this is the lactate here on the other side. I emphasize this lactate because this is very important to human being. But this is not used to produce energy to human being. This will not participate in our Krebs cycle. Okay, in our citric acid cycle. So it is just stopping there. Ganon. So it should be minimized, the lactate, because the lactate will steal the oxygen in your cycle. Then if the oxygen will steal in your cycle, then you will have less oxygen, then you will become weak, and that's the reason you will have disease. Okay, meaning to say, if you are sick, if you have disease, your lactate level, okay, is very, very, very high. You get the point? Ganon. Because it will consume your oxygen in your system. Oxygen in your bloodstream and oxygen in your lungs. So the doctor will measure this. Okay? So if your lactate is within the range, meaning you are healthy. Okay, so this is not our emphasis because this will not participate in our citric acid cycle, but this is only dagdag kaalaman that this pyruvate will also produce lactate in the other side. Okay, of your entire, chemical process known as. But we cut it because I need to discuss a citric acid cycle only. Okay, things like that. You get the point? Ganon. But here, guys, okay, be careful also. In your pyruvate oxidation, there are also coenzymes. Ganon siya, guys. It's not only the enzyme, but there's also coenzymes. Helper enzymes to help the pyruvate dehydrogenation. Moto siyang ADP will convert to ATP, and then NAD will convert to NADH. Things like that. Okay? Here. The same also glucose here. There's also a helper here. Helper. Okay, we have also the NADH and 2 ADP, NET, and and also 2 NADH. Things like that. Okay, in your glucose. This is important because we need to add that somewhere in our cycle to become 38 ATP because our body needs 38 adenosine triphosphate. 38 atoms. Things like that. Okay? So, as we go along the way. Okay? Ganun siya. So, we need to, because gamera kayo ang akong whiteboard, then we need to erase. Okay? Akong i-erase mga kalangka akong ikan. You got the point? Okay. Mukhaon kong kuan. Charot. Okay. So, intermittent fasting ha, si Junjun. Okay. You get the point. Luwi yung makuan. Ma-erase. Charot. Okay. Like that. But before anything else, we need to familiarize the formulas. Okay, this is very important, guys, Formulas. Why? Because it contains oxygen, carbon atoms. Oxygen really is useful in our inhalation and breathing. Okay, that's the point. So things like that. That way, nakakaluka, di-absorb. Evaporation takes place. Boiling point, 100 degrees Celsius. Wow. My gosh. Wow! Water molecules. Charot. So, this. Okay, magsugod ito sa proper niya ano ha? Okay, ganun siya. Charot. Okay, so if we have now the pyruvate oxidation, then it will also produce the acetyl CoA. Oh, ganon. So before acetyl CoA, it will be produced also, this is comes from the pyruvate. I will not put the pyruvate, it's understood. Okay, you got the point? So that it can be occupied in my whiteboard. Okay, so after the pyruvate, because I showed a while ago, right? So we have also acetyl CoA dehydrogenase enzyme to produce acetyl CoA. Okay, so we need to say all our process here is rapid oxidation. Okay, in the cycle. You get the point? So, ganun siya. Okay, atong ituyok ha, atong ipadapling siya para masudit ang tanan. Sarach! Okay? So, ganon. Kakaloka. Okay? So, mga palangga kong hitad. Okay. So, it's gonna be like that. So, magduin na lang kung bilingin na ano. Oh. Big circle like this. Okay, class. This is big circle. Okay, so we start with acetyl CoA here. We'll enter the circle or the process. Acetyl CoA. Okay. This is coenzyme. Okay, coenzyme A and acetyl. Acetyl is containing 2 atoms of carbon. Okay, from acetate. Okay, for example, you have the apple cider vinegar, right? So, or the vinegar in your kitchen. So the vinegar formula is 2 atoms of carbon, 3 atoms of hydrogen, and 2 atoms of oxygen. This is the vinegar formula, or the acetic acid, right? Like that. So this is vinegar. Now, take note, there are 2 atoms of carbon. So meaning to say this acetate is 2 atoms of carbon also. Okay, attached to a certain enzyme. It's like coenzyme A. Ganon. Okay, you got the point. Things like that. Okay, so after that, okay, we will produce citrate. I already discussed citrate, right? So citrate is really the source of all here in your citric acid cycle, of course. Okay, so I need to research the formula. Okay, C6H5O7 raised to the power -3. Actually, and it can also be C6H5O7. Okay, because in organic chemistry, the citrate and the acid will just be used interchangeably. For example, you said malate, it's also malate acid, like that. Fumarate is also fumaric acid. Citric acid, okay. Hyaluronic acetate, or hyaluronic acetic acid, things like that, okay. You get the point. Okay, mga palangga kong hitad. I mentioned hyaluronic acid because that is a chemical used for, increasing the nose lifting, or, nose lift. You have to put chemical known as hyaluronic acid. Okay, without hyaluronic acid, your nose will not be elevated. It will put in the nose bridge. Okay, silicone is not enough. Okay, there's a chemical hyaluronic acid to put when you try to have surgical operation in your nose. Okay, so that's the importance of the hyaluronic acid. Okay, and then if you take that into your nose, it will hydrate your nose. So there's water. So that's why it will not become dry. Then bingo. So it's very good. And you have to maintain the silicone also, like that, blah blah blah, so and so. So expensive operation. Okay? So what I'm trying to emphasize, hyaluronate is also hyaluronic acid. Things like that. In organic chemistry only yeah, but in organic chemistry, no. Okay? First of all, sulfuric acid, we will never say sulfurate. is also the same as sulfuric acid. No, it's not. Okay? You got the point. Not siya. So citrate. So when you produce citrate, what is the enzyme? Like that. So the enzyme will be, this gonna be citrate. Okay? Synthase. Wow. Synthase. You get the point? Citrate synthase. Ganon. Okay. Then after that, it will produce isocitrate. Okay, the isomer of citrate. Okay, like that. The orientation will change. That's why it will become an iso. Okay, just like propyl alcohol, the isomer is isopropyl alcohol sold in the market. So things like that also. Citrate, isocitrate. Okay, meaning the same, but only the structural orientation has been changed. So that is isomer. So what is your enzyme for this, for isocitrate? Okay, your enzyme will be, so, aconitase. Very difficult, right? Aconitase. Wow. Try to memorize the phase on it. E-H-A-S-E. Okay. Okay. So you will, in your memorization, you will say ako sa Bisaya or sa Tagalog, ako. So it's easy to memorize the enzyme of isocitrate. Start with ako. So the rest will follow ako. Ako ni phase. So Bisaya. Pero madali mong memorize na ako ni phase. Okay, for the isocitrate. Nga naman ko sa college, if there is a Bisaya term or Tagalog term that I can include in my technique and strategy so that it can easily be memorized, I will apply. Okay, things like this. Ako ni phase. Ako ni junjun. But the junjun will be replaced with phase. That's why ako ni phase, and that is the enzyme of isocitrate for easy memorization only. Okay. You get the point. After that isocitrate, okay, it will produce here the alpha ketoglutarate. Okay. Ay nako, ketoglutarate. Okay. And then ketone, meaning this is a ketone group, and this is alpha. That is in the first carbon of the ketone. That's why alpha ketone. And then the glutarate, it looks like complicated, right? Glutarate. So it is derived from glutathione, and the salt will be ATE, glutarate. Get the point? The salt of glutathione. Things like that. You get the point? So glutarate. Okay, this is not glucose because it could have been gluco. Ketoglutarate, but it's not gluco, it's gluto. That means glutathione. It is the salt of glutathione. And add with the ketone, that's alpha ketoglutarate. Wow, just a glutathione, yes, because this glutathione is a antioxidant. Okay, antioxidant meaning it's helpful to prevent bacteria to come in your system. Okay, so not only it is known for this to whiten your skin, but there is more major use of glutathione is being an antioxidant, and it is branded as the mother of all antioxidants, more than the ascorbic acid. Imagine. Okay, but we are only knowing that the ascorbic acid is good as an antioxidant, but there is more powerful the glutathione. Get the point? But the glutathione will not function the same as ascorbic acid, but we're only talking for antioxidant because ascorbic acid will act as a vitamin, but glutathione is not a vitamin. Okay, it's only to whiten the skin and to remove the free radicals of the virus and the bacteria and any antigens. Okay, but the ascorbic acid is good for the health kasi. Okay, that's only the advantage for ascorbic acid. But in terms of antioxidant, application, glutathione is more than the ascorbic acid. Okay, you got the point. So ganon. So others are buying this through intake. Okay, so while you are whitening your skin, at the same time, you're also preventing virus to come in your system. Right? Di ba nakakaloka? Okay, that's the point. So alpha ketoglutarate. Okay, this one. So what is your enzyme for this? So this is alpha ketoglutarate dehydrogenase. Okay. So your technique really, guys, is to follow only the product produced and then just add dehydrogenase. Okay, in your memorization. But not all, at least there is like that. Okay, so after alpha ketoglutarate, like this, ganon, here, next cycle, it will produce succinyl. Okay, succinyl, CoA. Oh. So we have another na. So the first our raw material is acetyl CoA. So we have also CoA coenzyme here. Okay, like that. But take note mga palangga, once it is an CoA, the enzyme to catalyze the reaction is not dehydrogenase. Put that in your brain cells, ha? If that is a CoA, okay, coenzyme A or like that, succinyl CoA, acetyl CoA, blah, 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 so on. So your enzyme to catalyze the reaction is not dehydrogenase. But other than that, dehydrogenase in your Krebs cycle. So that's easy memorization. Okay, things like that. You get the point mga malalakangitan. So your enzyme now, again, copy the para produce succinyl CoA, okay, synthetase. Wow. Nagkalisod, synthetase. You get the point. You will add just T in the phase, THESE, the same with the citrate, and the aconiphase in the succinyl. Kung ano dyan yung THE na. Succinyl CoA synthetase. So that is our enzyme to produce succinyl CoA. After that, it will produce succinyl acetate. Okay, succinyl acetate. Why? Remember our raw material have acetyl. So of course, it will yield acetate in that. Succinyl acetate. Okay, this acetate comes from the acetate in your raw material. Okay, so succinyl acetate. So what is your enzyme here? Okay, so succinyl acetate, because this is now not CoA, so succinyl acetate dehydrogenase. Okay, so muna siya mga technique chuba-chucho. Okay, then after that, this is cycle, it will produce, okay, a fumarate. Okay, fumarate. Okay, so here in the single chuba-chucho, single word, okay, not double word like that, and then things like that. So it's no longer dehydrogenase, ha? So the enzyme will produce fumarate is fumarase. This is now very easy. Fumarate, so from the word only, so fumarase. Okay. Things like that. Okay, and after fumarate, it will also converted to, okay, malate. Okay, malate. Okay. So malate. Because malate will be here because of the production of the maltose sugar, disaccharide. Okay, related here, ha? Malate. Maltose sugar. Meaning, disaccharide, glucose plus glucose. Okay, so it's also matching because our raw material here is glucose. That's why when you come here in the malate, there's a lot of glucose. Because malate come from maltose. In which maltose is equal to glucose and another glucose. And our raw material is glucose. So di ba, nag-match siya? So hindi siya nagpataka ba? Okay, mutungay dun siya kamatuuran. Get the point? So if malate coming from maltose, then maltose is also glucose plus glucose. Of course, natural because our material in the glycolysis is glucose. Here also, succinyl acetate, natural because our, our starting point in our Krebs cycle is acetyl CoA, so acetate. Like that. Okay, so in your memorization, it will help a lot to make it faster. Okay, so the enzyme that will produce malate, okay, is, okay, malase. Okay, like that, malase. Charot. Okay, you get the point? Malase. Anak siya mga palang kapangkitan, ha? Okay, then after that, the last will be the oxaloacetate. Oxaloacetate. Again, there's acetate. Pasok sa banga. Okay, you get the point. So oxalo meaning there are 4 carbon atoms. Okay, then what is your enzyme to produce oxaloacetic acid? So very clear. Okay, oxaloacetate dehydrogenase. Okay, like that. And then it will go back to acetyl-CoA. Back again, travels back and forth, travels back and forth. Things like that. Okay, now, in here, I'm not yet illustrating the energy consumption, energy produced of its chemicals or substance here from, from citrate going to, or from acetyl-CoA going to oxaloacetate. I'm not really emphasizing yet. So in the citrate, you will produce, from NAD to NADH. Okay, like that. And then for aconitase, from isocitrate, you produce also NAD, NADH. Okay, from alpha-ketoglutarate to, succinyl CoA, okay, you will produce CO2, like that. Okay. Now, from succinyl CoA to succinyl acetate, you will produce the FAD to FADH2. Okay. Now, for succinyl to fumarate, you will produce from ADP to ATP, like that. Okay, things like that. And then for fumarate to mannose, you produce NAD to NADH, and then from malate to oxaloacetate, you will produce CO2. Right. Now I will explain why. Okay, as you can see, the CO2, 3 CO2, right? 1, 2, 3. You get the point? Ganon. 2 CO2, 3 CO2. Why? Okay, steady lang sa diha ako. Explain ka ako. All. Okay, 3 CO2. Why? Okay. Now here, okay, so it's very obvious that this 3 CO2 is in the downstream. So plus upstream pa siya. May mo siyang 6 CO2 dapat. Okay? But this is only downstream, it's a 3 CO2. Okay, you get the point. So, our NADH, ipako no pila ka buok. Charot. So, 1, 2, and 3 here, right? Dili sa mali. Okay, NADH. 3. So, 3 na siya. So, 3. This is downstream, right? So, times 2 is equals to 6 NADH. Like that. Okay, get the point, mga palangga kong hitad. Now, in a pyruvate also, mga palangga kong hitad, di ba, pyruvate oxidation before it will become acetyl-CoA. I told you a while ago, I illustrate in my first half of my discussion that it will yield NAD to NADH. Right? This is also 1 times 2 because downstream and upstream. So, 6 plus 2, that is 8. So, 8 NADH. Like that. Now, in your glycolysis pundo dito sa raw material drug sugar, we have also NADH na 1, so 1 times 2, 2. So, meaning to say, 8 plus 2, 10. We produce 10 nicotinamide adenine dinucleotide. Okay? 10 atoms in our citric acid cycle. Okay? To complete the energy requirement of human being. Things like that. You get the point? So, 10, ha? Now, CO2, manatano, and then we go to FADH. We have only one here, right? And it's oxygen chupa-chucho. Okay, so FAD will be converted to FADH2. And then this is only downstream. So, the upstream, so times 2, that is 2. 2 FADH2. This is simple mathematics, right? Okay, and then we have also after that, the ATP and ADP here. Okay, the adenosine diphosphate will be converted to adenosine triphosphate ATP here. I will explain why. The ADP will be added by a phosphate called ATP synthase. Here, enzyme. Okay, like that. So, because it will produce electrochemical gradient protons when the electrons are being released in this, in this cycle going here in your mitochondrial matrix. Things like that. Okay? Because the point mga palangga ng itag ganun siya. So that's why it will produce ATP here. Okay? So 1 ATP here, downstream, above also that is 2 ATP. Okay? So how many ATP now? And we have also in the pyruvate oxidation prior to COA, we have also 2 there. And we have also here 2. Okay, so 2 plus 2, mga palangga kung hitad, that's gonna be 4, right? Really? Yes, 4. Okay. 4 ang atong ATP. Kanatay pundo nga sa glycolysis nga 2. Okay. So look at the commonalities. We have NADH, FADH, and ATP. This is not common of the 3, right? So how can you do that? This is not common to the 3. So we need, just like mathematics, we need to get the common denominator like that. Okay? Less common denominator. Okay, or get this common factor. So this is not common. So which is our common here of our Krebs cycle is to produce energy in the terms of ATP. So we need to convert this NADH to ATP. We need to convert FADH to ATP. How can we do that? Let's do the chemical reaction. Okay, I will erase now this one, ha? Let's go to the chemical reaction. Okay, so that we can understand. Okay. Okay, like that. You get the point? Oh, ganon. Nakatandok. Okay. So, saan yung oras ko yung char? Nakatandok ka. Hindi ba? Urasan na ako kinabuhi, char. Okay. So, balik ka sa atong general equation. Okay. Okay. Mga palangga. So as you can see ha, na mga NADH, so we need to say, so, di ba, nicotinamide, adenine, okay, dinucleotide. So klaro tayo pasok sa banga, mo produce siya mga substance for our DNA. Okay? You can produce deoxyribonucleic acid, it will be added with, adenosine nucleotide. And this adenosine nucleotide is the same adenine in this one, NADH. Okay, that's why it will produce ATP also because that is adenosine TriPhosphates, also from adenine. Okay, so things like this, there's a lot of adenine that is useful for our DNA. The point, because DNA, deoxyribonucleic acid, it contains nucleotide basis adenine to have the product. Like that. So, klaro kayo sa banga, pasok sa banga, kailangan mga adenine sa atong Krebs cycle, or else it would be nothing. The Krebs cycle will be nothing. Okay, so that means it is very helpful because it can produce the genes of the human being in our genetic factor. Okay, so muluwa din siya guys, consistent din siya guys, ano? Okay, at the point, mupasok din siya sa banga. Okay, so we need to say if we don't have the citric acid cycle, so obviously we don't have the DNA, right? Because because nucleotide is a component of the DNA. Okay, and then it needs nucleobases, adenine, cytosine, guanine, uracil, and thymine, and adenine is picked up here in our in our Krebs cycle. Okay. Yung nasa book, why adenine? Because that is DNA. You are not focusing with RNA, with ribonucleic acid. Okay? Get the point? Ganon. Okay, so, bubalik ka sa general formula. Okay? So, the entire process guys is aerobic cellular respiration, in which glycolysis, pyruvate oxidation, like this, Krebs cycle, electron transport is only part of the entire cellular respiration. Get the point? You get siya. So glucose, okay, C6H12O6, okay. Okay, kaparat malugas, because I need to explain manggod, madugay ko. Okay, C6H12O6. Hindi ko mo diretso ba? So C6H12O6 plus oxygen gas is equal to CO2. See? Lugwa na po ng CO2 sa atong Krebs cycle. CO2 plus H2O plus ATP. Lugwa na ang ATP sa product. Now, in our product, there's no FADH2, there's no NAD, there's no ADP, there's no FAD, and so obviously we need to convert those substances into ATP because that is not found in the product. Okay, so how can we convert that 10 NADH? 10 NADH. Okay, and then we have also the 4 ATP, right? Ganon. Get the point? And we have also the 4 ATP. Ano? This is FDH2. I-convert pa man nila to. So the 4 FE, okay? FADH2. Makalibog yung FADH2 eh. Tinawag yung substrate po eh. Nakakaloka. Diba? So, ganon. So, ano siya? FADH2. Why 2? Because upstream, downstream. Ganon. So, di pa uli pa yung mga you need to convert this to ATP. So, how can we do this? Then there's also three atoms, okay, 3 moles of CO2, right? In our Krebs cycle. So, we produce this. We can never add this because it has not the same variable. Just like math, you cannot add directly X and Y. Okay? Also, NADH and ATP, you cannot add that one. Also, they are not the same substance. So we need to convert this into a common substance, which is the energy source, which is the ATP. Okay? You get the point. Anak siya. Okay. So, adenosine TriPhosphates. So there's adenine in our DNA. That's why. Okay? You get the point. And triphosphate, because phosphate will be converted into phosphorus, which is very, very important in our bone health, bone remodeling to avoid osteoporosis, together with the collaboration of calcium and vitamin D and magnesium. These are the group of nutrients that will fight the weakening of our bones, but mainly the calcium. But we cannot do the calcium without vitamin D. Because vitamin D will do the absorption of calcium. That's why vitamin D and calcium are jowa or manag-asawa. Okay? You get the point. But ang ilang mga cousin relatives mo, sila si magnesium, si phosphorus, para lang hindi sila tuyo tumong sa buko. Get the point? Ganon. So we have 10 NADH here. 10 NADH. Okay. So reaction na yun. So, in every one NADH, how many moles of ATP? Ganon. So, since based on my memorization, because napapagod ako mabalance-balance, actually, kamarang mabalance, no? Ako na hindi memorize na siya 6 moles of O2. Ikaw, looking ko mo, di ba? So, 6 moles of CO2 and 6 moles of water. Memorize na lang siya dito. Okay? So, the memorization is very easy because you only add 6 moles in your cellular respiration chemical reaction, and there's no 6 moles in the glucose. Okay. Now, if you have 6 moles of oxygen gas, 6 moles of carbon dioxide, 6 moles of water, what will happen to your ATP? Okay, what happened to your ATP? Okay. So this is directly proportional to the CO2 and the water and the oxygen gas. Because you know, the glucose will split. Okay. Dili siya proportional because the glucose will split chuba-chucho. So, ayan proportional lang ang 6 moles of oxygen gas, 6 moles of CO2, and 6 moles of water. Okay. Now, so, actually, you'll put that here, 6, right? But, we are focusing only the downstream in our cycle na to. Okay, so we will say, in every 1 mole of NADH, we have 3 moles of ATP. So, cancel NADH. So, 10 times 3, we have 30 moles of ATP. ATP na siya. And the 4 ATP, pasok sa banga. So, how can we convert to FDH2? Okay? So, Ano na po din mo? 2FADH2. In every FADH2, how many ATP? Okay, how many ATP in FDH2? Okay. Imo yung hunaon. Okay. Pila man. Remember, ang FDH2 doesn't participate in the general equation. Only the ATP here, huh? Okay. You get the point. So how can you do that? Okay. So if we have, so again, if FDH2 doesn't participate in your general equation, okay, that's why you will never use 3 moles of ATP. Like that. So how can you do that? For that. Okay, so we have 1 ATP, or 1 FADH, 1 ATP, right, in the downstream, right, and we have also 1 ATP in the upstream. Okay, so to compensate the 2 FADH in your both upstream and downstream. So you will say, in every 1 mole of FDH2, there will be 2 ATPs, both the upstream and downstream. So cancel the FDH2, 2 times 2 is equals to 4. This is 4 ATP, right? And you have also the 4 ATP here, okay, from the glycolysis and to your downstream and upstream, right? You see the pyruvate, it doesn't participate, so 4 ATP. Oh, all our ATPs now, the main source of energy for all photosynthetic living organisms for survival in the planet Earth. That is the purpose of ATP. So wait, so 30 plus 4 plus 4 is equal to 38. Okay, human being needs 38 moles of adenosine triphosphate. Okay, for our main source of energy, first. Okay, second, for our DNA. Third, for our bone health. Okay. So, para itong pasok sa banga, bone health. If our bone is strong, then it will give us energy. Correct me if I'm wrong. That's why there's a phosphate here in the ATP. Phosphorus. Okay? Like that. You get the point? And this phosphorus came from the sun. Huh? Because the sun has element phosphorus. Okay? Muna yung tinubdan sa phosphorus tanan. Absorb na sa mga plants. Padung sa tao. Atong naging mong pagkaon ang kuan plants. O mga animals. Ang animals mo, absorb na sa phosphorus. Inhale mo na siya dito. Okay, get the point? Makaon na sa tagbaboy, mga anak. So, napay phosphorus daghan. Okay? You get the point. Mo-ari nyo rin siya, mo-apel nyo siya dali sa last. Okay? So, 38 adenosine triphosphate. Ganon. Okay. So, for the healthy bone, okay, DNA, and for our energy. Energy meaning for our muscles, tissues, and all vital organs. So, pasok sa banga, right? Again, our ATP, 38 moles of ATP, main function is for our energy. That comprises of to give energy or to activate our muscles, tissues, and all our vital organs. Okay. Now, it will also improve or have an adequate level of our DNA, our genes. And of course, it will also develop our bone health to make us strong. Of course, energy galit. Okay? You get the point? So, muna siya ang tinugdan ng ATP. You get the point? Ganon. So, balik-balik ako na siya dito. Okay? Ikalibang, ganon. Manghihi. O, balik ako dito sa kuhan, atmosphere. Ganon. Kaloka. Okay, panghihi. Ito naman sa soil. Mikas sa soil. Sa ilaw mo, paano sa siya evaporate. O, balik na po. Nakakaloka. And then fossil fuels, ganon. Degradation of human manure. Like that. So it will become also a source of our energy again. So that is, renewable source of energy, right? Fossil fuels. Renewable. Because it will manufacture again and again and again. So that's also coming from the animals. For example, their manure, it will go to the soil. It will degrade for how many years, how many months, and it will also expose to the atmosphere through natural reaction, the evaporation, whatever. Okay? So, and also the human being also. Okay? Because there's a septic tank there, and then after that, it will release also to the soil. Of course, kung wala siya, kung ano, mapuno ang septic tank. So, mumukuan dyan na, tuloy siya sa yuta. Okay? Again, evaporate takot, gano'n, ma-absorb dito. So, mabalik na po siya. You get the point? Gano'n. So, it's a cycle. So, lakot pa kaso, di balik na po na itong kaon ng akong mga kain. O itong mga ihi. Di ba? Kaya mag-grow mo na ang mga plants. Tungod sa manure, may ana sa fertilizer, yung apil ba yung manure sa tao? Huwag mo tingaasa ang tayo sa tao di ay. Huwag tanggay na. Evaporate mo na ang yung kuan. Diba? Kinabot yung mga protein, mga waste products, ang mga bilirubin. Okay, we discuss. Buntag na sure. Okay, that's the point. Gana. Any questions so far for the citric acid cycle? Nothing, right? Okay. So, gana. So, if you love to do this, you have to take units of biochemistry and biology. But if you love to study only, then study. You can learn by it, even though without taking units. Okay? You get the point. It's like that. Thank you so much for watching this vlog regarding citric acid cycle. One main source of energy also to produce ATP. Okay? So you can share this video to anybody else. You can click the notification bell for some news updates of I am a singer to know. I'm not a singer. Science, health, safety, and music. I changed my, my YT channel. Okay? Shout out to those people that requires me to change. This is for their recommendation. Okay? You get that? But because they found out that I'm no longer singing there. And then my title is still I am a singer, eternal voice, but my topic are already science. So they are correct. So I changed my YT name. Okay, get the point, mga panakakita. Okay. Thank you so much. Bye-bye, guys, everybody. See you later. Char. Ganon. Diba, guys? Kapoy ano yan? Talagang go.